COGEN Europe commissioned Artelys to conduct a study on the role of CHP towards a net zero energy system by 2050. Christopher, can you illustrate the process and the main results?
Yes, sure. So this study has been performed in the context of a climate neutral scenario inspired by the 1.5 tech scenario of the European Commission. In this scenario, we see that thermal power generation is still required, in particular during periods where heat is also needed in buildings and industry. These technologies use biomethane, hydrogen produced by electrolysis, or methane produced from this hydrogen. The key question becomes to understand the role of cogeneration in such a context, since using CHPs is more efficient than generating electricity and heat separately. The study has proceeded in two steps. First, we have investigated the business case for CHPs by comparing the economics of a situation with CHP to a situation without CHPs in 7 use cases, from residential to industrial applications via district heating or provision of heat and electricity for hospital, using different CHP technologies from fuel cells to turbines or engines. The key finding here is that CHPs are found to generate savings from the end user point of view in most use cases, and even more so when accounting for the avoided grid losses and network reinforcement costs. Based on this finding, we have investigated the system-level benefits of deploying CHPs at the 2050 horizon. To do so, we have optimized the deployment of CHPs using an advanced interlinked modeling tool called Artelys Crystal, and found that the replacement of part of the gas-fired power generation fleet, as well as part of the gas boilers, has multiple benefits. In summary, the study has shown that, taking into account their impact on capital costs, CHPs reduce the overall cost of the transition by providing savings in terms of fuel costs, thereby reducing CO2 emissions and participating in reaching a carbon-neutral economy more cost-efficiently.
Hans, the study reveals many interesting points, but why can we say that CHP has an important role to achieve carbon neutrality in Europe by 2050?
Good question. In 2018, our sector adopted a new vision for the future. This vision is supported by our 60+ members spanning the entire energy value chain. The vision outlines the cogeneration's commitment to creating a resilient, decentralized, and carbon-neutral energy system by 2050, with cogeneration as its backbones. Cogeneration, or combined heat and power, is a key enabler to achieve carbon neutrality in Europe by 2050. Prioritizing cogeneration for thermally generated heat and power in all sectors will maximize energy efficiency and integration of European energy system at least cost. The Artelys study shows that cogeneration enjoys a widespread support in the EU and beyond as a solution of choice across all sectors. Furthermore, it indicates that there is a cost-effective potential for 40 gigawatts of additional cogeneration capacity to be built between now and 2050. So this is in addition to what's installed today. This will bring efficient, flexible, and affordable power and heat to hundreds of cities, industries, as well as millions of citizens. An ambitious and predictable regulatory framework for cogeneration is imperative to fully reap the benefits of efficiency and energy system integration for citizens, businesses, and the energy system between now and 2050. There are multiple benefits that are presented in the final results of the study, including but not excluding all of them, savings between 4 to 8 billion euros a year in terms of cost for the energy system, anywhere between 150 to 250 terawatt hours energy savings across the energy system, about 20% reduction in the remaining CO2 emissions that will exist in 2050, which will be already relatively low, so that'll be a significant contribution as well. And we see that CHP will represent anywhere between 13 and 16% of total electricity. And these are just a few of the key takeaways from the study.
Nick, as a user of CHP, what should be the role of CHP in 2050? And what are the key takeaways from the Artelys study from your perspective?
You see, the aim of the study is actually to bring the notions of energy efficiency first, primary energy efficiency and resource efficiency back to where they belong, at the top of our climate and energy agenda. Now, for industrial consumers, such as ourselves, we operate a high-efficiency CHP to feed heat into our alumina plant. Ensuring continuity of heat supply is absolutely crucial, but this needs to be done in the most resource-efficient and cost-effective way possible. Now, installing a large industrial-scale CHP can lead to energy savings which can even rise up to 700 gigawatt hours per year, or roughly 3 to 10 million euros of cost savings. And these benefits are on top of the system level benefits that CHP provides. That's minimizing system losses, avoiding taxes, and so on. Now, although the Commission has repeatedly recognized the importance of efficiency as a notion for the successful transition, primary energy savings and resource efficiency have unfortunately been completely overlooked in the recent years. So CHP achieves rates of even 90% in overall efficiency, and that's by far the most efficient, actually available way of generating heat and electricity. Nonetheless, most recent legislative texts, including the upcoming Delegated Act on Taxonomy, accompanying the Sustainable Finance Package, utterly fail, unfortunately, to account for this way that the technology functions, and thus they set some impossible thresholds. Now, being sustainable is not just cutting emissions. Clearly, it's not just cutting local emissions, right? So in some sectors, aggressively cutting emissions in the EU may actually contribute to an increase in global emissions, and that's highly relevant for our industry as well. Also, in the view of the EU's recent awakening to strategic autonomy. Sustainability is, in fact, achieving the optimal balance for meeting present needs and avoid compromising the ability of future generations to do so. So meeting our needs in a cost-effective and resource-efficient manner is essential, but looking at the impact of the trajectory towards climate neutrality on the entire climate and economic social spectrum is equally essential. Now, energy efficiency isn't just about buildings or lamps. In fact, if one looks closely at the Commission's 2030 impact assessment, it's acknowledged that the benefit of energy savings might not be enjoyed equally by all citizens, because households with a lower income might lack the access to capital necessary to invest. This is where primary energy savings come in. So high-efficiency CHP must be prioritized as the optimal technology for the production of power and heat, and must get rewarded for the overall system efficiency it achieves. Affordable and sustainable energy, that's electricity and heat. That's the secret behind high-efficiency CHP. Last but not least, it's genuinely fuel agnostic. So when we manage to decarbonize our gas grids, efficient cogeneration will actually be carbon-free too, at least as carbon-free as all other currently available power heat generation technologies. Thank you.